Dominik Halbeisen from the Swiss Railway Company, or SBB. So welcome, Dominik. Can you hear us? Can you join us? Yes.
And clear. Also, late welcome from my side. Thank you very much, Branimir.
Thank you, Dominik. Dominik is a senior project manager for supply chain projects, also a GS1 standards expert, and we've been working on them for the last couple of years actually together. Can you maybe give us a bit more intro of what have you been involved with the Swiss Railway and how are you working with GS1 standards?
Yes, of course. I will just in a second dive a bit deeper into the subject, but the main driving force for us has been the following. If we even want to think about digitalization, exchanging data and information in regards to maintenance, replacement, and overhaul components, then we first need to get our identification in place and make sure that it is reliable. And that's where our paths have actually crossed, Branimir. Once we had that in place, the question has come up on how to best start sharing and exchanging data. And the reflections and actually the thinking behind it and the ideas that we have developed and come to learn, that's what we would like to dive into in the coming 50-ish minutes.
Awesome. Thanks, Dominik. So just for everybody to be acquainted with the rest of the schedule, right now we're going to actually dive deep into something called the EPCIS, Decentralized EPCIS repository, which we've been working on together. Dominik will present how and most importantly why this has been a focus for SBB. And then afterwards we will be joined by none other than Phil Archer from GS1 to discuss a bit more on how such systems and networks can be built for different industries. So Dominik, if you're ready, feel free to go ahead and share a screen and let's get started. All right.
Just start the presentation.
Yes, we can see your screen. So
you should see the presentation now. Can you confirm that?
Yes, we can see it.
In presentation mode.
All right, let's go.
So we are good. Thank you very much. So again, welcome from my side. Actually, just to go back to Branimir's question, we tried to actually put it down in a drawing, and this drawing has been our guideline over the past few years, actually already 3 to 4 years. And as you can see in the drawing, that's the evolution that we have gone through. It's not a revolution, it's really an evolution. So in the beginning, our main issue was about speaking the same language. We knew we had integrated supply chains, we had the same suppliers, we had the same value chains, but we were identifying the same components differently. So this is something we had to work on first, and we did it by developing and adapting GS1 standards to the needs of our industry, which differs in one very important aspect. Objects live up to 60 years, so we are way beyond consumable lifespans, and objects come back or refabricated and return to the field in a modified version. So in other terms, we needed to get the identification of parts aligned that our grandfathers designed and manufactured and make them ready for our grandchildren. So this is actually what we had to do. The next thing which then came up is how do we use this? How do we actually exchange data sets which come from a standardized numbering scheme in such a way that we can start sharing business data across company borders? Of course, the GS1 system has a solution ready for that, but I just want to give you a very short intro into our experience so far. To show it in rail terms, this little orange sign there means if you see the longer track, at least in Switzerland, Work in progress, reduce your speed. So when we started the journey of sharing data, it looked very easy at first. Let us assume we are company A with an ERP also called A. And we have the brilliant idea of wanting to share information with a company B, which of course runs another ERP, let's call it B. Nothing easier than that. We sit around a table, or at least virtually around the table. We map the data we want to share and let's go. Of course, I'm simplifying a bit, but the main idea is roughly that. Of course, once word spreads, other companies want to join. So another company with ERP A joins. It also uses the existing mapping to the ERP B, and the network expands. With its growing success, new players come into play. Suddenly on the horizon, the fourth player, now running ERP type C, appears, and the mapping exercise has to be repeated. No big deal. The energy, time, and money you have to invest into this exercise is still at a scale where everybody can live with it. So we go. The whole network becomes a successful story. More companies start to join. And the further we expand our scope of application, the more we start encountering even more ERPs. And now you see where this is getting very slowly. It becomes step by step, through its success, a problematic proposition, a runaway equation. Why? We have already a certain size of a network. And once something from outside this network appears on the horizon, wants to connect to it, it has to start connecting to each and every variation in the network, as shown here by company D, which has an ERPD and now needs to map to C, A, and B. Okay, let's say that we accept this additional workload and this change, and can then capitalize on the mapping put into place also for ERPs type D. The success can then further accelerate, of course, until E comes up. And it becomes ever more difficult to integrate new players with different ERPs into something as complex as that network which has evolved. But let's say we actually accept that challenge and overcome it. We can start growing even further until F appears on the horizon. And you see that this runaway equation is not only a runaway thing, but it is self-destructive. The bigger it gets, the more exclusive it becomes, the harder to change. And if something cannot change, it is doomed to stop working gradually and over time. And precisely this thinking and this challenge has driven us to look for other solutions. And we have, based on GS1 standards, developed an EPCIS in Rail language. There is an industry standard freely available on the internet. And why have we done this? For a few important reasons. First, we looked for a solution which can translate from your ERP, in our case being from our ERP, into one language only, so that we do not need to worry about everybody else, but we just translate into a data English, so to say. And that means that the mapping and the attributes, and there are many attributes, just needs to be defined once. And this in turn allows for something which we call network providers. We will have a look into it in a second, which in turn has again a huge impact on architecture. To very quickly sum it up, we have gone into standardization in order to be able to just translate from our ERP language into a common language, have the mapping definition made just once, and by doing so, allowing for a completely new architecture setup. let us return to the scenario we had before. Again, we want to start to exchange data. We have ERP A, and we want to connect to B. However, this time we do not go there directly, but we go via a provider. And we connect to the provider by using the GS1 set of rules and norms, meaning that we translate from our ERP to an EPCIS message and send this EPCIS message to a provider. Why is this interesting? For a very simple reason. Whoever joins the network just needs to join in relation to one network provider. It is infinitely scalable. So whoever adheres to a network does not influence what has already been done. He just joins up or he leaves. And what's more, once we encounter networks which, like mushrooms, are starting to grow all over Europe in the rail industry, we also do not need to be worried. As long as we follow the same standards, we just created a data exchange channel between the two networks which have come up, one centered on our company, for example, another one centered on another large player in the industry. And this allows for further scalability and especially for a very quick time to market. So the expansion becomes exponential. Of course, looking at this, questions come up. At this vast space, and this is where we want to go. We are looking at this galaxy, at this vast space of points and possible relations. And the following questions come up looking at this vastness. How do I find the right and complete information? The potential space we're looking at is so immense, so huge, that it becomes a true challenge. Do I even know all the parties that are publishing information in relation to a certain part I have in service? How do I control what I'm sharing? Even though I have a component installed in my infrastructure or rolling stock, and I share data in relation to it, I don't want everybody to be able to read all the data. So permissions become an essential aspect. And of course, how are we kept up to date? We cannot go out there and query the whole galaxy time and again. We need to find a solution to obtain notifications in relation to objects that are of interest to us and to disregard what for us is just background noise. Of course, for others, it might be important. And how do we actually create those tunnels, those wormholes to the other networks coming up and being built all around us, also based on GS1 EPCIS standards? So to very quickly wrap it up, we have come from identifying parts to exchanging data about the parts identified, to coming to understand that if we want to exchange data in a way that is not a runaway proposition and thereby self-destructive, we need to follow a certain set of rules, which in our case is an EPCIS in rail rule set. And once we do that, we are theoretically able to connect all the different points in the galaxy. However, how do we do this? And that's where we have found OriginTrail and the technology that goes along it. So for us, this was the right fit. It actually answers the above questions. And how it answers the above questions, that's something I would like to hand over to Branimir to show us.
Perfect. Thank you, Dominik. That was a great presentation and great intro. So I will continue. I have a couple of slides. Can I ask you to just move to the next one? Of course. Thank you. Before we go into the demo. So we'll be talking about the decentralized EPCIS repository, which I introduced at the beginning. And what it really does is it actually tackles these problems that Dominik has shown us on the previous slides. So can we move to the next one, please? All right, so the decentralized EPCS repository, we built as a global decentralized network of really company-owned EPCS repositories. And in that sense, we're tackling the first of the three main issues that are part of what we have just seen, which is really the infrastructural issue. Instead of having the network, the growth of the network be a problem, we're harnessing the network effects. And in that sense, actually following the Metcalfe's law. Metcalfe's law being that the value of the network grows with the square of the number of its participants. And by the way, one of our previous mentors. So what this infrastructural issue really means? Well, if we are able to get all the required integrations in a way that there is no need for a central provider, rather than a network of different entities that can communicate to each other, we're able to harness this growth of the network to its advantage. And as you can see, the problem was that it's really hard to integrate point to point, hard to manage how it actually grows into this galaxy. Well, the idea here would be that just as today you can sort of buy a modem and connect to the internet, you can do that through the decentralized EPCS repositories and start sharing data, EPCS events, particularly with the partners across the world. And how do you do that? Well, you do that through EPCS push and pull choreographies. They're defined by the standard, but basically mean that you can either push events out, send them over to everyone, or replicate them, or pull the events. So you can basically ask for specific identifiers or anything of interest that you can really pull the data in your way, basically. What the decentralized EPCS repository then tackles as the second problem is really the data. So obviously the common language is used, which is EPCS and associated standards, but also more importantly, it tackles indexing. So what Dominik just said is, how do you find the right data in the right spot? Well, that basically means that we utilize the decentralized knowledge graph, which is used to index information, be that private or public information, in order for you to be able to actually ask that. So think of it as a book, and you can turn to one of those back pages and you can see a certain term showing up on page, I don't know, 253. Well, that's basically one of the bigger parts of the system, or the decentralized knowledge graph, which is actually the substrate for the decentralized EPCS repository. And how do you do that? Well, you can access the specific information using identity-based access control. That solves another issue, which is, who are you in this network? And in this case, the decentralized EPCS repository utilizes W3C decentralized identifiers and verifiable credentials. Very interesting upcoming standards, which basically set the stage for decentralized identity rather than specific vendors that are brokering this identity, such as, for example, vendors today, which we all know of, such as Google or Facebook, which basically allow you to log into different websites with their credentials. So the key thing here being that there is no central authority, everybody's responsible and actually has the control of their identity and has the ability to find any piece of relevant EPCS structured information on the network. The final problem is also how to get integrity of this information. So if you're looking for something and you find something on the network, can you really trust it? So that's where the verifiable integrity comes from, the underlying DLT technologies, which is really the OriginTrail and blockchain networks. And finally, the decentralized EPCS repository is fully based on open standards and open source software. So moving on to the next slide, I'll just quickly explain the OriginTrail protocol for those of you who might not be familiar with it. It's basically a decentralized network hosting a decentralized knowledge graph. It is not a blockchain, rather than a peer-to-peer network that is able to communicate, enables nodes to communicate between each other and to actually share the information in the same way I explained it on that particular example of EPCS, but also supports different data models as well. It's compatible with multiple blockchains and it's really a neutral middleware for trusted data exchange. So again, it's not a consensus-based network. It actually utilizes blockchain for when consensus-based operations are needed. So as you've seen, for example, in one of the previous sessions with the Oracle blockchain, it actually sometimes provides input for the blockchain smart contracts, where on the other hand can also be leveraging the data that's on the blockchain, such as fingerprints that it utilizes, or identifiers, or particular implementations of decentralized identity. Essentially, it's designed to augment the existing systems to help them share information. And moving on to the next slide, and I promise that's the last slide, and I'll go into the demo. A really quick intro into the decentralized knowledge graph. So think of it as a big graph of data, and that's really linked data. So the idea there being that we're not talking about documents. We're not talking about specific separate files or specific documents that are being kept in different places. We're speaking about linked documents, linked data, files that somehow link to each other, very much like hyperlinking on the web, which we're all very familiar with. So think of the internet without hyperlinks. That's basically, it's very hard to navigate it. And that's where the decentralized knowledge graph helps, because you're able to link both public and private data with the same protocol. And then it becomes a different thing whether you're able to access a certain piece of data or not. So that means that there's a global public graph that has attached subgraphs of each organization that is participating in this knowledge graph. And if you look at the illustration, you'll see two subgraphs that two organizations, A and B, are able to actually share and automatically connect to the main, we can call it spinal knowledge graph, in public knowledge graph in the middle. And it utilizes really all of these standards that I have mentioned previously. So to show you how this works, and a very prototype example for the EPCIS repository, I'll actually go ahead and share my screen. So I just need someone to confirm. All right, I got the confirmation, and I will try to just move the Zoom thingies out of the screen. All right, so what we're looking for at here is another application built in the network operating system, or NOS, by Tracelabs. And we're looking at two companies. This is company one, and on another screen, I'm actually going to show you company two. And these are their decentralized EPCIS repository nodes, or really nodes of the OriginTrail network, which have a specific identity and a specific associated wallets, which are actually utilized for this centralized identity. These nodes actually are connected through the network and are able to share information. And I'll really quickly explain how. So basically, the EPCIS push choreography is what we're going to be seeing here. So we're going to look at ingesting EPCIS data. So this is an actual visual interface that anybody can really use here, but this is not the only interface. So there's obviously an API behind all of this that anybody can really use. And what it really does here is it enables upload of data sets. So I'm going to upload a data set from my one of the demo data sets I prepared. And essentially what happens right now is that this data set has been uploaded on the NOS and checked for GS1 compliance. You can actually even look at the data set. So we see that it's a GS1 XML file with certain interesting attributes, some of them actually involving permissioning. So permissioning can also be done on the data set level rather than actually going into later stages, which can also be done. So later all of these elements can be permissioned along. And there's two levels of permissioning at this time. So you can either take the whole attribute and make its value permissioned, so hide that value for anybody who should not be able to see it, or you can take the whole attribute and hide even the whole attribute as here. And what we're looking at here is really a very simple EPCIS object event, which is actually of a component moving along the supply chain in progress, actually 5 different EPCs. And once this has been uploaded, imported, I can actually go ahead and publish it to the network. So I'll click that, and that publishing actually triggers the EPCIS push choreography. So right now what's going on behind the scenes is that the actual OriginTrail node has been receiving this data. The data set has been imported and being published to the OriginTrail network. That means associated fingerprints are being also put on the Ethereum blockchain in order for anybody later to be able to validate two things. One is that the data set has full integrity in terms of not changing its data, and the other is that the actual identity of the issuer, or in this case, company one, is really their identity. Now, this publishing lasts a couple of minutes, and because we don't want to spend all that time, I'm going to show you, on the other hand, as company two, how I would find some data that company one has already published previously. So we're going to use a GS1 identifier, actually a GIAI, to search the network. Very much like Google, we have a search box, but also obviously behind the scenes, there's an API doing that, and the API runs a distributed query. So the query along the decentralized knowledge graph asking nodes. And we actually got a data set back with a certain identity and a certain issuer identity. And when we view this data set, which takes a moment to load from the actual graph, we're able to see that this data set has been published by company one, the actual account that I have published the other data set previously, that it is an EPCIS 1.2 data set. It's been published as a verifiable credential. That means we can do such verification as here on the right. So we can verify the data publisher. Actually, the code in this application does that automatically behind the scenes. So it verifies the publisher signature and identity, and also verifies that the data model is correct, that the replication has been done on the network, so that all the necessary elements to the data are in the decentralized knowledge graph and the blockchain, and finally that all the necessary fingerprints match. So that can also be viewed directly on the blockchain itself, because that can also be performed without the need to trust the interface or any other component, but rather having the ability to do that yourself. And then finally, just as the end for the demo, what's also very interesting is that apart from having this data only in EPCIS format, the ability of the knowledge graph is actually to relatively easily transform this, such as what Dominik already has mentioned, was really mapping a certain ERP system to EPCIS, and well, naturally that mapping has to go back, right? So you have to take from EPCIS and go into your ERP. So you can download the EPCIS data set, but you can also download an example JSON data set, and that is, by the way, this type of a JSON data set is, just move this off the screen, is actually very close to what the new GS1 EPCIS 2.0 standard is going to look like. So what we're looking at here is actually the XML file. And as you can see, some of the elements that I've shown previously are no longer visible because they've been permissioned. So this particular company cannot see it. And on the other hand, if we look at the JSON file, which I'll also open here, we see that basically this is structured as a JSON LD document, or essentially a graph, which one can then convert and very easily actually map to their own ERP. And then finally, to look at all what's NOS and OriginTrail capable of really here, is actually an array of different data models and standards that are supported. So we've discussed EPCIS, obviously, but also core business vocabulary, which is a necessary component to it. The GS1 digital link as one of the key new developments, with the GS1 enabling connection of the physical and the digital world, but also Web of Things and verifiable credentials and decentralized identifiers, all of these very interesting upcoming standards. And I will be ending the demo here. It's actually a good segue going forward into the discussion with one of the people that is actually responsible for these standards. So I would really like to welcome Phil Archer to join us